Okay, for some reason at the end of that last video, it just didn't like the after the 4 turning points. So let me just go ahead and explain that. We have 4 turning points. So according to our formula, n minus 1 is equal to 4. So we solve that and we get n equals 5. So therefore we know that this polynomial, if it is a polynomial, is at least a 5th degree. Now it could be more, but it is at least a 5th degree. Okay, let's start our next topic, which is the end behavior of a polynomial. And all polynomial graphs exhibit end behavior. And one way we can figure out what that end behavior is by looking at its degree and looking at its leading coefficient. Well, if we have a polynomial function, a sub n x to the nth plus, and then this goes on for a while in between depending on the function, a sub 1 to x sub 1, and then our last term, which is a sub 0, which is our constant. The leading coefficient that we're looking for is right here, a sub n. So as our x values move without bound on the left and the right, the graph of the polynomial eventually rises, which we're going to classify as going up, or falls, which we're going to classify as going down, in the following manner. So here's just some visualizations of what's happening at our end behavior. Okay, so our first example, if our leading coefficient, which is a, is greater than 0, which means it's positive, and the degree of our function is even, like 2, 4, 6, 8, 10, then the end behavior of our graph is going to be going up on the left and up on the right. So whenever your degree is even, they're going to be doing the same thing on both sides. Okay, the next case, if our leading coefficient a is less than 0, which means it's a negative number, and our degree is even, then both behaviors are going to be going down. So down on the left, down on the right. Okay, let's look when our degree is odd and our leading coefficient a is greater than 0, which means positive. And you can see from the graph that they're going in opposite directions. So on the left, we're going down, and on the right, we're going up. And then if our leading coefficient is negative, which is less than 0, and our degree is odd, things are going to flip around, and now we're going to be going up on the left and down on the right. Just want to point out here, this is what the end behavior is looking like. This part of the graph is going up, but this is a decreasing section of our graph. This is an increasing section of our graph. So increasing and decreasing are different than end behavior. And then you can see the dotted lines are just indicating that in between the end behavior there can be a lot of stuff going on depending on what the degree is. And we're going to figure out what's happening in the middle here in just a little bit. So let's take a look at a couple examples. So state the end behavior of each function without graphing. Well, if we take a look at our function p of x, what is our leading coefficient? Well, our leading coefficient is negative 4. So I just abbreviate the LC of negative 4, which obviously means it's negative. And then what is our degree? Well, our degree is 6. And 6 is an even number. So if you look back at what we have, if we have a negative leading coefficient and an even degree, that's the case that we have right here. So that means our end behavior is down on the left and down on the right. Okay, our next example. Again, let's take a look at our leading coefficient. Well, there's no number there, but if there's no number there, it's 1. So our leading coefficient is 1, which is positive. So leading coefficient is positive. And what is our degree? Well, our degree is 5. So our degree is odd. If you look back up at your table, that means we're going to be down on the left. Oops. And we're going to be up on the right. So not too difficult, you just have to remember what's going on with each one of those.